Welcome to Module 1 of the No-Code Blueprint, How Software Solutions Work. In this module, we're going to cover off three key areas, and that is firstly, what do we mean by software, just to make sure we're all talking the same sort of language. Second, we're going to look at the key benefit of software and why software really came about, and that is process automation, simply put. We'll look a little bit more into that. And then in the final section, we're going to look at software architectures, some of the key software architectures that exist today. Just a word of warning, it is a little more technical, probably more technical than you need to know. But I think the key relevance is just so you can understand some of those software architectures that are available and out there today that you use on a daily basis, probably without thinking about. And also what the key one is that we're going to be applying most of the concepts in this course too, but more about that a little bit later. So firstly, what do we mean by software? Well, essentially software is a set of instructions that tell a computer what to do. Software is normally made up of programs, procedures, and routines. And broadly speaking, we can categorize software into two broad areas. So firstly, we've got system software, and this is software like Mac OS, Microsoft Windows, and the various flavors of Linux that run computers, and also things like your smart TVs. You'll find some specialist system software running your Samsung and LG or Sony television. Next then, the second category is application software, and these are things like Microsoft Office, computer games, and websites or platforms like Airbnb. Again, things you use on a daily basis. This course is going to focus on the design and development of application software using no-code tools. So no doubt in your mind you have an idea of some form of application you'd like to build, and you'll be wanting to use no-code to do that, and that is really what we'll be focusing on. Before we get into some of the detail around the architectures, I just wanted to spend a brief moment talking about the history of software development because it goes back a lot longer than you might expect. This is not meant to be an extensive history lesson, so here are the highlights that I've drawn out. There are early references to Ada Lovelace, after whom the Ada program language is named, and she wrote programs for Charles Babbage's analytical engine, thought to be the first computer. However, it's only with Alan Turing where we start thinking about stuff moving into the sort of mainstream, and he was credited as the first person to come up with a theory of software in 1935, which ultimately led to the fields of computer science and software engineering as we know them today. The 1950s then saw the development and use of languages like Fortran, which is formula translation, and COBOL, which is the common business-oriented language. In fact, COBOL is still in use today and was meant to be a business-friendly programming language rather than one used specifically by computer scientists. Software development then formed an integral part of the Apollo space program in the 1960s and 1970s. And software development then continued to grow with the launch of the Apple I computer back in the 1970s. And later on with the growth of the IBM personal computer in the 1980s, and this brought us programming in languages like BASIC, Pascal, and C, and they all became very widely used. In fact, variants of them are still used today. With the commercialization of the internet since the 1990s, software development really exploded. The emergence of Silicon Valley, for example. There's just too many options to discuss in this course, but probably worth a bit of reading outside of this course. It's also worth noting, however, that during this period we saw the launch of consumer applications such as VisiCalc, Lotus 123, and Microsoft Excel. As things now stand, Excel can probably be considered as the grandfather of no-code. Countless organizations and even households run on applications developed using Microsoft Excel, and I'm pretty sure you use the tool on a daily basis, either for work or within your home. In fact, as you progress your no-code journey and are looking for ideas to build, you can think about anything implemented using a spreadsheet as being a great candidate for being built using no-code technologies. Right, it's also worth considering newer technologies then, such as artificial intelligence and machine learning. Whilst these are topics on their own right and have courses focused exclusively on them, it is worth exploring these in a little bit more detail. I think outside of this course, AI and ML are fairly specialist, but have also now started making their way into the no-code world. There's several no-code platforms actively using AI, for example, Notion, and the tools themselves are becoming easier and easier to use for no-coders. Lately, we've seen the massive uptake of ChatGPT, which was launched by OpenAI. This definitely is a disruptor, and it's lowered the barrier of entry, as we already seen solutions built on no-code platforms incorporating this technology. To give an idea, on the platform side, we have things like Amazon AWS Machine Learning, Microsoft Azure Cognitive Services, Google Cloud Machine Learning, and IBM Watson. When these technologies come to life, we find ourselves interacting with services or applications like Apple Siri, Amazon Alexa, and Microsoft Cortana. And whilst you might not be incorporating AI and ML into your applications right now, it really is something to keep an eye on. Right, so section number 2 of this module was all about process automation. And the big question really is, why is software important? Well, by and large, as I said in my introduction, it's about process automation. Take any process that might be very laborious. Think, for example, of sending a personalized email to your email list of thousands of subscribers. Done individually, this task would take hours. And with a software solution like MailChimp or MailerLite, this can be accomplished in minutes. Or think about running a project and having hundreds of post-it notes on your wall, representing your Kanban board. What a hassle updating things or moving things around. Now with software like ClickUp, Notion, or Trello, this really becomes effortless. There are loads more examples when you start thinking about things like banking, accounting, and even customer management. And this is where software development and software products can and do add significant value, and where you as a software developer, even if it is no code, can build valuable software products. Right, in the third section now, we're going to look at software architectures. I'd like to cover the core software architectures. There are several, so I'll touch on some of the more notable ones. Using no-code platforms, you generally won't need to worry about and don't need to worry about these architectures. They're just good to know about, especially the last one, because we'll base most of the concepts on this course on the last architecture. So here we go with the slightly more technical bit. So firstly, we have client-server applications, and these are things such as email and sometimes banking. Many business applications in the 1990s and 2000s were built on this architecture. And this pattern consists really of two components, a server and multiple clients. The server component will provide services to multiple client components, and clients can request services from the server, and the server provides relevant services to those clients. And furthermore, the server continues to listen to client requests. So simply put, you log into Outlook, you say, download my mail. Outlook, being the client, goes to the server, which is your Outlook server or other email provider, pulls those emails down. So very simple, two-way communication. And also an example there was some form of banking as well, banking applications. Next, we've got peer-to-peer architectures. And in this design pattern, individual components are known as peers, so of equal standing compared to the client-server sort of relationship we talked about before. And peers can function as both a client requesting services from other peers and as a server, so providing services to other peers. And a peer may act as a client and as a server, or as both, and it can change its role dynamically as time changes. Some good examples here are file sharing applications or platforms like Pirate Bay, but also blockchain is built on this peer-to-peer technology. So again, very relevant to all of the stuff that is happening now in the blockchain and crypto world. Next, we have the event bus architecture. As you can see, it's a little more complex, so not worth going through all of that detail really. But just to let you know, this is essentially how the Android operating system works, and also Microsoft HomeKit. Apple HomeKit. I'll be in trouble there. Next is the model view controller architecture, also known as the MVC pattern. and it divides an interactive application into three parts. Essentially a model, which contains the core functionality and data, the view, which displays the information to the user, and more than one view may be defined, and then controller, which essentially handles the input from the user. And this is really done to separate the internal representations of information from the ways that information is presented to and accepted from the user. It decouples components and allows efficient code reuse. And this is the architecture that's used for many World Wide Web applications, and covers web frameworks such as Django and Rails. Next is the interpreter one, and even if you don't know this architecture, you probably work with it sometimes or often, maybe on a daily basis. And this pattern is used for designing a component that interprets programs written in a dedicated language. It mainly specifies how to evaluate lines of programs known as sentences or expressions written in a particular language. And examples of this are SQL, structured query language. So simply put, you can create dynamic commands like select me all the records from this table, and it'll return a list of all the records, like customer names, for example. Or more pertinent, and I've listed out Excel VBA here, Visual Basic for applications, and this allows you to extend the functionality of your Excel spreadsheet by including some process and programmatic type of processes in it. Also available in things like PowerPoint and Word. And then finally, and probably definitely the most pertinent to this course is the layered architecture, because this is what we're going to build on many of our concepts in this course. And this pattern is used to structure programs that can be decomposed into groups of subtasks, each of which is at a particular level of abstraction. So obviously you'll see the stuff facing the business user, or the user is the most abstract, but each layer essentially provides services to the next layer. And the most commonly found four layers of a general information system are the presentation layer, also known as the user interface, the application layer, also known as the service layer, the business logic layer, which is known as the domain layer, and then finally the data access layer, known as the persistence layer, so essentially where the data is all stored. And you can see, going back to the sort of core components that we spoke about earlier, you can almost see them grouped into those three areas we spoke about: data, business logic, and a user interface. So that concludes module 1. Hopefully the last bit's not been too technical. Feel free to kind of watch it through again. Also, if you have any questions, just get involved through the chat and ask those questions in the courseware, and I would be happy to answer any of the questions we have. I look forward to seeing you in the next module.